Yeah, now after we have heard so much about the system and the added value, I will start, I will try to summarize for those who have not been so much in contact with the data, how to download the data, how to start using it, and so on. So I will, that's actually my agenda. So I will briefly give an overview of what kind of training material is actually available already now on the C3S websites, and then we will dive a little more deeper into the training material that we are developing in the contract. Jupyter Notebooks, how to download and plotting in comparison with ERA 5. So it's mainly for newcomers, but I hope that there's something in it for everybody listening now. So for the C3S training material, so in general, there are the Copernicus user learning services, which offer quite a lot of material. And I would actually like to show this website, some examples, only briefly, what is already available. So there are e-learning modules, and also Jupyter Notebooks. We can have a quick look on one of the Jupyter Notebooks, which give good introduction. And since we're here focusing on reanalysis, we could look actually here on the tutorial quickly using reanalysis data. And so far, all is based on ERA 5, but hopefully, perhaps there will be also some Jupyter Notebooks for CARRA be added here on this web page. And here we have Jupyter Notebooks that you can run. If you log into one of these platforms, you can produce all the figures, you get a lot of explanation and so on, and that's something similar what we are also preparing for CARRA right now. So now I have to check how I can go back. No. Here, exactly. So we can have a quick look at the e-learning modules. So there are a lot of courses and paths where you can learn about all the different data sets and the CDS, so the climate data store and so on. So again, we could have a quick look at data resources, reanalysis, just how such a course looks like actually. So these are really like online courses where you can learn now in this example about reanalysis. You can learn what is actually reanalysis, how a reanalysis is produced, overview about the data sets and so on, and strengths and weaknesses. And yeah, since these are real lessons, actually at the end, you will also find some questions where you can test yourself if you understood what the lesson is about and so on. So you can learn a lot about the data sets and how to handle that, and their path is on that available. So too much slides open. No, wait. I wanted to go back to that one here. So we had a quick look at the e-learnings and the Jupyter Notebooks. On top of it, there are also training events provided by Copernicus, and you're just attending one of them. So there are workshops and other training events you can find on the Copernicus webpage. You can also find user stories where users show how they're using data sets or something to inspire you. I would actually also like to mention the VQ cloud infrastructure. There are also a lot of Jupyter Notebooks, so you can just create an account there, and VQ has actually also direct access to the CDS, so Copernicus Climate Data Store. You can download the data there. You can work on the data. You can produce plots, whatever, and then get the data there from there or the figures. There's also the open source EarthKit project, which is a tool developed in the league by ECMWF, handling these data sets and also the visualization of that. So if you're new to all these data sets and Copernicus and the CDS, I can really recommend to do some of these lessons and get started by looking at the available material. And now a little bit more about CARRA specific. So now we go into how to search and download the data from the CDS. Then I will show how to download 1 month as example data, how to compute the monthly mean and plot it as a map. We will plot differences between CARRA and ERA5, and then also plotting a time series. So if you're interested in CARRA data and you have not downloaded it yet, you start actually by visiting the Climate Data Store, which is opening here. We have to create actually an account to download the data at the end, but at least you can search for it also without an account. And just by searching for CARRA, you will see that there are actually different data sets available on different level types, model levels, height levels, pressure levels, single levels. So let's check for single levels, where it's actually the 2-meter temperature available. As an overview, you get a description of the data sets and all the different variables. And if you're interested to download the data, you go to this tab here. You select if you want data from the east or west domain. I will do this a bit quickly. Surface, atmosphere, we have the 2-meter temperature here. We have to go to all of that. So there are analysis and forecast time steps, as we learned. So now I would like to download all the analysis. So every 3rd hour, select all of them. Let's say we do it only for the very last month which is available, so the near real-time updates. Select all the months, all the days, and we want to download the data in BIP format. Then you can here with a button at the very end, you can actually see how this request looks like. So here actually you get the Python code which you can use to download the data. So that's how you find the data and how you get first information on how to download it. So what you need to install is actually the CDS API. After logging in, you will get actually your account credentials, which you have to put in your home directory in this in the file here called CDS API RC. And then you have to accept the terms and conditions of the data set you would like to download. Okay. And now we will actually see this example on how to get the data, how to download it in an example. So now here in this example, I took the source code or the Python code from the CDS.
Semyon, I think you have to zoom in a little bit if you can. I don't know.
Ooh.
Is it?
I don't know. I can try.
Too close?
Oh yeah, let's see. Perfect, that's working. So here's the example. The source code here is based on the source code that I took from the CDS actually, which was provided there. So what are we doing? We download single level data from CARRA, west domain and group format and so on. So what we're downloading here is 2-meter temperature and only the analysis time steps. The only thing actually that I changed, just in case you are not interested only in downloading 1 month, so I actually have here year and month as a variable, and then it's possible to loop over the months that you're interested in. So here I set only start and end date to 1 month only. So this script will actually download only 1 month. But if you're interested to load longer time series, that's easily possible by adjusting these numbers here. And then here we see, actually, I'm not running the scripts now live. I don't know, live is always kind of risky. So I run the scripts, I see last time on Tuesday, and it took here about 30 seconds to download this data set. 1 month of data of 2-meter temperature was downloaded successfully. If you're downloading longer periods, it might also take longer. Some of the data is on is not on disk available, it might be on tape, so then it can take longer, but usually it's quite fast. Yeah, and then I did the same exercise actually here for ERA5. It's looking basically the same. Here I'm not looping over everything, so I took actually the source code directly from the CDS example, and you see it was also downloaded in no time. And that was actually the first script. So then you have the data available on your computer or wherever you are, and on the Jupyter Notebooks or cloud. So then we can go on with the second script and check how to handle the data set.
Zoom in again.
Zooming again, yes. So like that, perhaps. So what do we do at the beginning? So we have to import some libraries to handle the data. So I'm importing now NumPy and xarray into my environment. I'm defining where the data is located that I downloaded and yeah, give it a name. And then the data set actually this time, so it's downloaded in group format. So and the group data is then loaded with xarray open data set. That's simple. So that's only this one command line, and then also even computing the monthly mean. Now we have this the data set stored in the CARRA variable, and we just calculate the mean over the dimension time, so which will give us then the monthly mean. And you can also, since the metadata is actually also loaded and available in this variable, you could do aerial mean or whatever. So we see here the output, so that was done, the mean was computed and so on. And then for the plotting, I need to do some arrangements. So I change the description of the longitudes so that it covers actually it goes from -180 to +180 and not from 0 to 360. In case you have several parameters downloaded here, I fetch then I take only the 2 meter temperature and put this into a data set then. We change the original data is actually in Kelvin, 2 meter temperature. Here we change it to Celsius degrees, and with that we also need to change actually the attribute that the data set, that the metadata is actually still up to date. So we we change the metadata to degrees Celsius, and then we can do with a very simple plot function of this data set. We can use only CARRA and then the plotting function, and then we get such a simple plot, which is actually only plotting all the grid boxes, but without taking care of any projection or longitude, latitude, or simply the coordinates. But that's good to get a first impression of the data set, how it looks like, and so on. So we don't have coastlines, but we see, due to the change in 2 meter temperature, we see a high variability here in the coastal areas. And that was a simple plot to get started and perhaps to get an overview. And if we want to do more advanced plots, instead of doing the simple plot function, now we use matplotlib and Car2P. So importing also Car2P. Here to do the plot, we start a figure. That's what's interesting here, is then that we choose the projection Lambert conformal, and then we're plotting actually the data, really taking care of the longitude and latitude as it is in the original data. And that's what we're plotting here, is actually the temperature. Here's the data set defined. We can add more information to the figure, for example, as setting the title. I would like to see the coastlines now and grid lines and so on. And the color bar is specified. And at the end, actually, the figure is also saved here with that command. And the plot was produced. And that's how it looks like now with this more advanced settings. So we have now included the coastlines, for example. It's the right projection and so on. And what we see, what we've seen before, I mean, you see actually all the details of the different valleys and canyons and so on, exactly as expected. So that was the second script. And we go back, and now we check actually how we can compare between CARRA data and ERA5 data. Of course, you could just put the plots beside each other, but it's also possible, and that's what I'm going to show here, is actually doing interpolation from one grid to the other, and then taking differences also for the maps. it's similar as before, because these scripts are all running now independently. The data was downloaded, but I have to load them into the script here again. And for the interpolation, I'm here actually using the CDOs. That might be interesting for some of you who have not used the CDOs. I can at least mention that I think that these are really powerful tools. So CDO stands for Climate Data Operators. I don't know, there are more than 700 functions in the moment handling netCDF and drip data. And here I'm actually using only one command for the interpolation from ERA 5 data to onto the CARRA grid. And actually what we see here is this one command here. So with CDO, I do a remapping using a bilinear function. And what's needed for the CDO commands to do this interpolation between the grids is actually I take fCARRA is actually the CARRA data set, or the file that we downloaded. So the CDO is taking the grid description directly from the grip file. And as input file, so the file that we want to interpolate, that's the ERA 5 data. And that's specified here. And actually can also point out that the ERA 5 data is actually loaded as a netCDF file. So CDOs have no problem with handling the netCDF and the grip data files. So taking the grid description from the grip file of CARRA, taking then as input data ERA 5 as netCDF, it will output actually ERA 5 data on the CARRA grid and then as netCDF still. And that's the output file here. And then after this file is produced, I'm loading these data sets then really into the Python script. I have to do all the same exercises again with changing the longitudes and changing from Kelvin to Celsius and so on. So we can go on here. That's done. Exactly. There also the monthly mean was also computed. So now we have monthly mean for ERA 5 and for CARRA data available. And first plot that I do, same as before, same settings, is actually plotting ERA 5 as an example. And when you remember the figure of CARRA, we had here at least along the coastlines and over Iceland and so on, there were much more details. So ERA 5 is generally much smoother. And of course, it doesn't help only to do the interpolation onto the CARRA grid. You cannot add, you won't add information to it. So even though the data was interpolated to the CARRA grid, you have still the same information. And along the coastlines, you cannot see all the details that are available in CARRA dataset. And then the next step, we're simply plotting the differences, which is not complicated anymore after the interpolation to the grid, or the data is on the same grid. So what's happening here is then we use these longitudes and latitude information, and here actually then go to the right this here. To the right. So what's happening here is actually that we simply take the difference between the mean for June, the data that we downloaded, so ERA 5 minus CARRA data, and specifying here the limits, specifying title and so on, and then the figure is printed. And then we see the difference between ERA 5 and CARRA data for June 2023 on this plot. So something in the range between -10 and +10 degrees are the maximum differences here. And yeah, as we have learned before, the differences over the ocean, for example, are not that big, but in topographic areas, that's where we see the differences. Okay, I think that's the end of the third script. And then the last script is actually plotting some time series for a point chosen over Greenland. Again, same story. So now I'm using the interpolated, the ERA 5 data interpolated to the CARRA grid. These data sets are opened again. Same procedure here, changing from Kelvin to Celsius, loading some libraries which are needed for the plotting. And this time for the time series, actually, I decided to use Pandas, the Pandas package for the plotting. Here I I pick a grid point, which is located in somewhere in the middle of Greenland. So we see here I use the grid cells with this indices, but here we see actually that this is at 75 degrees north and approximately 315, so which is 45 degree west. And yeah, then we're creating out of these data sets or out of these grid boxes which are selected. And this time actually I did not do the monthly means, of course, because we want to plot time series. So based on these data sets which are chosen here, so which include only one grid cell, I produce or I change it into a data frame, into this pandas data frame, and then it's plotted with these commands. So it's simply that the data frame, the pandas data frame, should be plotted with figure size and so on. You specify font size and legends and some labels you can specify. And then we plot also error 5 on top of it and save the figure. And that's then the results of it. So now we have here temperatures, the 3 hourly temperature from the analysis, both from CARRA and error 5 for this one grid box in the middle of Greenland. And I don't know where to go to the right to see all the entire time series. And what we actually see is, perhaps I go back. Let me see which is what. So in blue we have CARRA and in red error 5. We see that the big fluctuations from day to day, so due to synoptic changes, they agree quite well, but the minimum temperatures, they're much deeper in CARRA than in error 5. And I think that's also something what we expect. With a higher resolution, we get more extreme values, though, of course, to really quantify if that's CARRA is better than error 5, we would need to compare with observations, but that's not done here. But that could be, of course, also included. Yeah, and with that, we went through all these 4 scripts, which are not really openly available in the moment. But there's no problem actually in sharing these scripts. I don't know if someone is interested just in the pure Python scripts or the notebooks. They might be shared. Just let me know that you're interested, or put it in the chat. And then hopefully at some point we will continue to work on that, kind of finalize these notebooks, and then they hopefully will become available on one of the Copernicus platforms. And I think with that,